Okay, thanks first of all for inviting me to present this our recent publication on the journal Landslides. Vittoria Capobianco, I'm currently researcher at the Norwegian Geotechnical Institute in Oslo, Norway, and I have a background in geotechnical engineering with a PhD on the effects of grassroots on the hydromechanical behavior of unsaturated pyroclastic soils. So I've studied how the presence of vegetation in slopes can both change the soil water retention, but also the mechanical behavior of root permeated soils. Right now, my research is still on landslide mitigation measures, looking more at nature-based solutions, which are solutions that use nature and natural materials to prevent soil erosion or to stabilize shallow landslide problems. And I'm involved in several both EU and national research projects. So with the presentation today, I will focus on this LaRiMiT web tool, especially looking at how we have updated the database of mitigation measures with this nature-based solution, and how we have provided this methodology for expert scoring of the candidate mitigation measures. So let's get started. I assume that most of you know that landslide risk is the combination of hazard and consequences, where consequences can be vulnerability and elemented risk. So to reduce the landslide risk, one should either reduce the landslide hazard and or reduce the vulnerability or exposures of elements at risk. So if we look at the framework for landslide risk management provided by Fell et al. In 2005, once we assess the risk, the level of risk, we do some judgments and we may assess whether this risk is tolerable or not. And if this risk is not tolerable, we need to reduce it. So we either act with non-physical mitigation measures, for example, by using early warning systems, or we may have a decision on risk mitigation options. So the idea of LaRiMiT goes hand in hand with the need to select the most appropriate risk mitigation option for a specific landslide case. And as you see on the left-hand side of this slide, conventional structural mitigation measures may be grouped in two main categories. We have the active measures, which are aimed at reducing the hazard. So basically, we act on the potentially unstable mass and we try to reduce the probability of the triggering of that landslide. And here are some examples of active mitigation. On the other hand, we may also act on the consequence side. So by implementing dissipation basins or structures that are aimed at dissipating the energy or containing the mass that is already propagating. So we allow the landslide to take place, but we try to reduce the impacts of the landslide on the elements at risk. So LaRiMiT stands for Landslide Risk Mitigation Toolbox. I invite you to just scan the QR code or go on the website. It's a free access website. The aim is to provide an extensive database of available landslide mitigation measures. So the landslide experts can look at them and can decide which risk mitigation option is the most suitable for a specific landslide case. And the idea of LaRiMiT is to assist decision makers for the selection of the most suitable mitigation measure. But also, it acts as a sharing platform for scientists, decision makers, policy actors that not only need to choose a risk mitigation measure based on the technical feasibility, but sometimes there are some other constraints, for example, related to the cost, related to the time of implementation, or the environmental impact of that landslide mitigation measure. So these are the four main questions that LaRiMiT answers to. The first one is, again, what are the options available? And this is done through an extensive database that you can check out with the description of more than 80 landslide mitigation measures. And then the other questions are they feasible? How expensive they are? What is their environmental impact? And the way LaRiMiT answers to this question is through scores that are provided by experts in landslide management. So each candidate mitigation measure has scores for different types of criteria that help the users to select what are the most suitable mitigation measure for a specific landslide case. And the way it's built is that there is an analytic hierarchic process that process the scores provided by users and then gives back in return and lists a ranked list of the most suitable mitigation measures. But I will explain more in detail this how it works later on. So as I said, we have experts and we have users. The experts are those that compile and update the database, and they are and also assign and update the scores to each candidate measure in terms of functional and technical suitability, reliability, feasibility, typical cost, and environmental impact. On the other hand, the user may either just check out the database of measures or may provide some information about the site-specific landslide condition. For example, what's the type of movement, material involved, depth of movement and rate of movement, or the surface and groundwater conditions. In addition to that, can give also weight to relevant factors that influence decision-making, which may be timeliness of implementation, environmental suitability, and economic suitability. So Uzielli et al., which were the developers of the LaRiMiT in first place within the project Climate 2050, provided this data flowchart just to show what are the main figures behind LaRiMiT. As I said, the experts provide general scores based on technical suitability and other factors for each candidate measure. On the other hand, the user inputs in some scores for those criteria that are related to the specific type of landslide they are dealing with. And the administrators are just managing the web portal and are those that have built in this analytic hierarchic process for the ranking algorithm, so that the result of the web tool is a ranked list of mitigation measures that the user can check out and see which are those that are most suitable for that specific landslide case. So going back to definition of landslide risk, we group the mitigation measures in two main groups, first of all. So measures reducing the hazards, the blue ones, and measures reducing the consequences. Those reducing the hazards are acting on the triggering, while those reducing the consequences are acting on the runout. And then you see 11 categories. The first two are in green because are the new ones, let's say, are the MBS that we have recently introduced, these nature-based solutions, which I will talk about later. The others are categories which basically group all the mitigation measures that are addressing the specific physical process of a landslide. So, for example, we see category 3 groups all the mitigation measures that are aimed at modifying the slope geometry, or we have some mitigation measures that are aimed at modifying the surface or the groundwater regime, or those aimed at modifying the mechanical characteristics, and so on. So here you see all the categories breaking down. So for each category, we have from 5 to 9 mitigation measures. And the green ones are, again, the nature-based solutions. So let's say that we want to use a mitigation measure for modifying the slope geometry or the mass distribution. Then we may have 6 options. For example, removal of unstable soil rock mass, or substitution of material with a lightweight fill, and so forth. So this is how the database looks like. And right now we have more than 80 mitigation measures updated and available on the database. And here are those for the reducing the consequences. Each mitigation measure has a description, has some pictures taken from examples of applications, has a description of design methods with the relevant references, and at the end of the page, you can just see and look at the scores that were given by experts in landslide management for that specific candidate measure. Recently, late 2019, we wanted to introduce new mitigation measures by including this new concept of nature-based solutions. So very briefly, nature-based solutions are actions that are aimed to protect, to sustainably manage and restore natural or modified ecosystems that are addressing some societal challenges, but that in the meantime provide also additional co-benefits, for example, benefits to the society or biodiversity benefits. If you look at the societal challenges that are within the framework of nature-based solutions, we have also disaster risk. So nature-based solutions used for landslide risk mitigation can be seen as belonging to this group of nature-based solutions acting on the disaster risk reduction. So the main difference between NBS and other conventional structural measures is that nature-based solutions not only act on the risk reduction, but they may provide also additional co-benefits that can be benefits to the society, for example, improving the quality of life, benefit to the environment by improving the biodiversity, benefits to the local economy by introducing new green jobs, and so forth. So when we talk about nature-based solutions in the framework of landslide risk, most of the time we think about use of vegetation. And use of vegetation or native living plant species or natural materials found locally is called soil and water bioengineering. So it's a technique, is a discipline that is already well known. Probably you're more familiar with this terminology rather than with nature-based solutions, because it's more for an engineering point of view. And it's the use of living material, both alone or in combination with inert materials, to construct structures that are aimed at stabilize slopes or reduce the erosion along slopes or river banks. And here is an example of soil and water bioengineering application provided by Stokes et al. In 2014. So you see the slope had a severe problem of surface runoff, surface erosion, and this is the design of the measures. So in reversed Y-shaped drainage system for the hydrological effect, and then some light cuttings put along the slope, as you see in this picture. That may provide also mechanical effects through the roots growing into the first layer of the soil. So here we have an example of how a nature-based solution for landslide application may look like. Recently, we have also tried to we published this opinion paper because we found that there was a bit of confusion of terminologies. So we wanted to clarify how soil and water bioengineering can be seen in light of this new concept of nature-based solution. So we did a recent comparison of terms and definitions, including also other terms that fall under the concept of NBS, such as ecological engineering, ecosystem disaster risk reduction, watershed management. And all of these terminologies were compared with the main aims of soil and water bioengineering discipline. And we concluded that basically soil and water bioengineering is a tool for NBS can be seen as part of nature-based solution, because nature-based solution is an umbrella concept, as long as we provide some biodiversity benefits. So it's important to clarify that it should not only provide erosion protection or can be used for disaster risk reduction, but should also provide some environmental benefits on top of the risk reduction. So at the end of this study, or this idea of including NBS measures in the LaRiMiT web tool, we also did an extensive literature review of soil and water bioengineering applications for landslide hazard and landslide risk reduction. Also looking at the reports provided by Geotechnical Engineering Office of Hong Kong and the European Federation of Soil and Water Bioengineering. And at the end, we came up with two main categories. The first one was NBS for erosion control living approach, and the other one NBS for erosion control living and not living approach. So for living approach, we mean only natural materials, only vegetation or live cuttings, etc. For a combination of living and not living, we may have also inert materials such as stones or rocks, etc. So here are the mitigation measures that we introduced. For example, hydroseeding, direct planting, or live patients, or brush layering, live stakes, and etc. And for the second category, we may have also a combination of living material with the geotextiles or drainage blankets and so on. All these measures were also listed and published on this report for the project Climate 2050, in combination also with nature-based solutions for other types of hazards, such as floods, stormwater, erosion, droughts, and etc. So you can just look at this report that we published in 2019. And after we reorganized the database of mitigation measures by introducing these nature-based solutions, we needed to update the scores of the mitigation measures. First of all, because the scores of the existing conventional measures were only based on opinion of a very few experts in landslide management. So they were not robust enough to be used properly. And in second place, we needed to provide new scores for these new nature-based solutions that we have recently introduced. So here you see the timeline of the survey that we sent out to landslide experts, more than 150 landslide experts and NBS experts in late 2019, with a couple of deadlines and then some reiteration to receive more responses, with the aim to update the scores on the website. And we proposed that expert scoring algorithm. I won't go in detail on the expert scoring algorithm, but basically we made this scoring, this algorithm in such way that we used it once to test out the methodology this time, but it can also be used in future because it's made so that it can be dynamically implemented. So as soon as new expert scoring are coming in, we can just use the expert scoring algorithm and update the scores of the mitigation measure on the website. And it's based on different phases. So we have a data analysis where we calculate the minimum, the maximum, the quartiles of the scores, and then we do some data filtering. Excuse me. Some data weighting, and then at the end we do a score selection and we update it on the website. Here is an overview of the experts that were contacted. I must say that the experts contacted were mostly people in our network and people that were participating to this ongoing project where LaRiMiT was developed. And LaRiMiT was basically meant to be at European level. And that's why most of the experts contacted were from European countries, with some extent to Asia and America. And you can see here the distributions of experts around the countries. And again, here you see most of them were from Italy or Norway, both from affiliation or origins, because the authors and the managers of the website were either affiliated or from Italy or Norway. And here are some results. So you see that at the end, among out of the 153 invited experts, about 25% of them replied, so contributed to scores for at least one mitigation measure. This doesn't mean that only 38 responded. We got only 38 response, but it means that one that responded could respond also to more than one mitigation measure. So at the end, we got a lot of responses for more mitigation measures than 38. And then you see that the majority of responding experts were, excuse me, the majority of responding experts were from Italian or Norwegian affiliations, followed by Spanish, Portuguese, and Chinese, and so on affiliation. Then we asked also the experts to qualify themselves in terms of profession, and about 40% were professors. The remaining 30% were practicing or professional engineers, and then the remaining were MBS experts or researchers, and only 6% were PhD students or postdoc students. Here is just an overview of the number of responses that we got. So on the right-hand side, you see the list of all the AD mitigation measures divided in categories, as I said earlier. And the colors mean MBS, the green ones, gray are the conventional, and purple are the hybrid solutions, which is a combination of both MBS and gray. And you can see that on this other graph, we have an overview of the number of responses for each mitigation measure. So, for example, here, 14 gray measures received less than 2 responses, meaning that we could not apply the statistical pooling, meaning that we could not update the scores because we didn't have enough responses. But for example, for the MBS, most of them received between 3 and 10 responses, so we could apply statistical pooling and we could update the scores. And only one gray measure received more than 10 responses. So in total, we received scores for 56 measures that were updated, while the others were not updated. And among these, 21 were nature-based solutions, 3 were hybrid, and 32 were gray solutions. You can look at all these results on our publication on the journal Landslides, where you can see also the discussion about this and how, for example, some mitigation measures receive more responses than others, and so forth. So here I leave you with some final consideration about this LaRiMiT. I briefly introduced the LaRiMiT web tool, how it looks like, how it works, how it's built, and how we updated the database with this MBS measures, and at the end how we sent the survey, trying to make the database more robust with more scores provided by a larger group of experts in landslide management. But the other idea of LaRiMiT right now, of these recent innovations in LaRiMiT, was also to allow us to disseminate examples of nature-based solutions for landslide mitigation by suggesting a portfolio of possible mitigation measures that engineers may be presented with, they are not familiar with, and may consider for potential landslide cases. So I just want to finish by saying that this project where LaRiMiT was born is Clima 2050 is ending this year, but LaRiMiT will be hosted from 2023 by NGI with the commitment to support the continuing development of the toolbox. It's an ongoing and it's a work in progress toolbox, because the future activities that we foresee is the addition of expert scoring, improving the underlying engine for selecting the mediation options, involving also more professionals to fill out the survey, and not at the least to validate the toolbox. Once we will have a large amount of scores, we may validate the toolbox with some examples and some real cases to be applied. So that was my last slide. I'm so sorry for my sudden coughing reaction. I don't know why, but I'm here to answer to questions if you have any, or just comments or whatever. So thanks again for giving me the opportunity to present our work.